Hi, today we are starting skill 5 on exponent properties. So this tells us like the rules of exponents. There's three main rules: product, quotient, and power. We're going to start with the product rule first. So it's telling us that when our bases, notice that our bases are the same. If we multiply with something with the same base, then we add the exponents. So we ended up adding m and n. So let's go ahead and practice this. I have the same bases. So I really have 3a's times 4a's, which is 1, 2, 3, 4, 5, 6, 7a's. Or I could have thought 3 plus 4 equals 7. I want you to pause the screen and do this one on your own. So write out all your b's and then add them and see how many you have. So pause your screen, do that. We have 4 b's and 2 b's, which gets us 6 b's total. Okay, we have y's and a constant. I'm going to go ahead and rewrite this with all my constants by each other. I have my 2 y's and my 5 y's. So I can multiply these to get a positive 12. 2 plus 5 is the exponent, or if you can do it in your head, it's y to the 7th. Or you could write out all of them and see how many you have. We're going to do this first one together. You guys are going to do the second one on your own. We're starting to get more and more variables. So I have my constants. I have my w's. I have my u's. So I'm going to do my constants, my u's, and my w's. My constants are 7 times 2 times 2. My w's, u to the 7th, u to the 5th. And now I can simplify those. 7 times 2 times 2. That's 14 times 2 is 28. I end up with 13 u's and then 8 w's. Let's go ahead and try that on your own for this one. Go ahead and pause the screen. My constants, my w's, and my y's. So that's what we'd have so far, and that's what you should have gotten there. We're now going to start doing it's called the power rule. When we have a power to a power, we multiply them. So we're going to go ahead and practice this. This is asking us to write it without parentheses. So you can think of this is like w to the third times w to the third. I'd end up adding those, and that's w to the 6th. Or you can think w 2 times 3. So this one I'd have x to the third times x to the third times x to the third, x to the 9th, or you can think x to the 3 times 3. This is the same idea, except now I have constants. So this is like 2 to the 4th times z to the 4th, or 1 times 4. There's an individual 1 there. Go ahead, pause your screen, try this one on your own. You should get 9 squared times b squared. This now just has 3 variables. So we would square everything. And that becomes 4 times 2. Go ahead, pause your screen, try the second one on your own. And that's what we would get. So we have an exponent in the denominator now, but that does not change how we approach this. That's negative 3 to the 4th. Oop, that'd be 1 times 4. Go ahead, pause your screen, try this one on your own. And that would be a negative because we'd have negative 5 negatives, which would still get us a negative. Okay, these are similar in the sense I distribute this negative 3, 2 times 3, 2 times 3, z is 1 times 3. And I get a 6, 6. So if I put all my x's together, my y's, x, y, z, if I simplify that, I have z to the 4th, y to the 9th, x to the 10th, and then a 1 times a 1 becomes positive. Go ahead, pause the screen, try this one on your own. We'll go through it in a second. So you're going to want to distribute that negative, or that 2 to each part. I get a 6, 6, and 8, so I'm going to put my constants, negative 2 times 9, my x's, my y's, my z's, and I should end up with z to the 8th, y to the 7th, x to the 10th, negative 18. The last rule we're going to talk about. Okay, the last rule we're going to talk about is a quotient rule, which means to divide. So when we divide exponents with the same base, if we divide anything with the same base, we can subtract the exponents. But sometimes this comes up to a situation where we get a negative. If we ever have a negative exponent, we make the reciprocal and put it in the denominator. So this will come up as we keep going. So let's think of it this way. This is y to the 3 minus 7, negative 4. A way to make that 4 positive is to put it in the denominator. Another way to think about this is I have 3 y's in the numerator, four y's in the denominator. I cancel out what I can, and I end up with 4 y's in the denominator. We're going to keep practicing this. Okay, let's look at 5 and 20 become a 1 over 4. I have 1 x in the top. I have 1 z in the bottom, and then I have with a y over y. I can think of that as 1 minus 1 is 0, or these divide to 1. And I have with 1x over 4z. Go ahead, pause your screen, try the second one on your own. 14 and 49 both are divided by 7. I get 2 over 7. I end up with a b, a d, and a c over c. These cancel out. And I end up with that. Okay, this is kind of combining a few of the rules. But I would distribute the 2, so I get 2 squared y times that. Should get me 4 over y to the 8th over 64 y to the 6th. Oh, 6 times 2 is 12. That's my mistake. So I end up with 1 over 16. 12 minus 6. I end up with 6 y's on the top. Go ahead, pause your screen, and try this second one on your own. I'd end up with y to the 6 on top and x to the 6 on the bottom. Okay, we've already talked about it. We're just going to continue to have more examples like this. But when you have a negative exponent, the way to get rid of the negative is to put the fraction on the other end of the fraction bar. So if I had 1 over 3 to the negative 2, I could make that positive by bringing it to the top of the fraction bar and putting it in the numerator. If I had something like this, I can make it positive by putting it in the denominator. So it asks us to rewrite this without an exponent. So first I'm going to get rid of the negative. 2 times 2 times 2 is 8. I'm going to get rid of the negative. I make it negative by bringing it to the numerator, and I end up with a 27. Something like this is different because we're going to talk about how to handle that negative sign in the front. That stays negative. My exponent becomes positive though. And then negative 7 times negative 7 is 49. I'm going to do the first one, you guys are going to do the second one. So I'm going to think that this negative 4 is only attached to the m. It is not attached to that negative 2. So to make it positive, I bring it to the numerator. Something like this. This negative 2 is only attached to the p, so my 4 stays on top. My negative 2 becomes positive by putting it in the denominator. We're almost done. Okay, I'm going to look at this as x's, y's. There's my x's. There's my y's. There's my z's. So if I think of it this way, I can think of it, I have x, negative 2 minus 3, y 5 minus a negative 1, z negative 7 minus 8. If I simplify that, I get x to the negative 5, y to the 6, z to the negative 15. Now I can get rid of each of those negative exponents. My x becomes in the denominator, my y stays in the numerator, my z becomes in the denominator. We can think of this as x or a's. And then that doesn't look good, never mind. So let's just try 14 divided by 4 is 4. My a's is going to be 3 minus a negative 7. My b's is going to be negative 6 minus a negative 7. Oh, a positive 8, sorry. And then I still have c to the negative 5. So if I rewrote all that, that's a to the 10, b to the negative 14, c to the negative 5. So my numerators, I have a and the 4, my b and my c go to the denominator. Sometimes you're asked to distribute a negative exponent. So I'm just going to give everything a negative 3. That becomes y to the 6, x to the 18, x to the 3, y to the negative 9. So my constants are a little harder to deal with here. We're going to deal with those in a second. Let's just deal with our x's. And x to 3 minus 18, y to the negative 9 minus 6. Oh, I made a mistake here. That should have been 9. So that's y to the negative 18. So they would be in the denominator. I'm going to go ahead and deal with my constants. I'm going to make my exponents positive. 3 to the third is 27, 2 to the third is 8. So I have 8 in the numerator and 27 in the denominator. This is a lot. Okay. I'm going to go ahead and just write my u to the third, z to the negative 1, x squared. I'm distributing this 2 now to everything. U to the negative 4, 3 squared, z to the negative 4. Let's go ahead and attempt to combine what we can. In my numerator, I see that I have my u to the negative 1 because I could do 3 minus 4. I have a z to the negative 1 and an x squared. So I'm just going to do my constants. X squared. Now I can write, I know my 9 is in the denominator, my u is in the denominator, my z is in the numerator, and my x is in the numerator. So this is all for skill 5. Good job, you guys.